If you ever needed to send a message at a specific time in the future, you know there's workarounds. External cron jobs, application level timers, maybe even abusing the NATS consumer knack with delay. None of these are clean and none of them scale well. Well, starting in NATS 2.12, JetStream has a native message scheduler. You publish a message with scheduling headers, and the server handles delivery at the right time. In this video, we'll look at how it works, the different scheduling modes, and where it fits in real applications. Let's check it out. So that's the problem. Deferred delivery without the plumbing. Let's take a closer look at how the message scheduler actually works under the hood and see what it looks like in practice.
Let's talk about scheduling messages in NATS. Sometimes you don't want a message delivered right now. Maybe an order should only go out at midnight. Maybe a reminder needs to fire in 30 minutes. Before NATS 2.12, there was no native way to hold a message for later. You could use knack with delay on a consumer, but that was a workaround, and it didn't scale. Starting in NATS 2.12, the JetStream message scheduler lets you publish a message and tell the server exactly when to deliver it. JetStream is the persistence layer inside NATS. It stores messages in durable streams so they can be replayed, filtered, and now scheduled. So how does the scheduler actually work? You publish a message with a special header called NATS schedule. That header tells the server when to deliver. For a one-time delayed message, you set it to @ followed by an RFC 3339 timestamp. You also set a NATS schedule target header to say which subject should receive the message. The server holds it and delivers at the right time. Here's the key detail. Each schedule lives on its own unique subject. The most recent message on that subject is the active schedule. Want to update a schedule? Publish a new message to the same subject. Want multiple independent delays? Give each one its own subject, like appending a UUID. But single delays are just the beginning. In NATS 2.14, the scheduler gained recurring schedules. You can use cron expressions, fixed intervals like every 5 minutes, or predefined aliases like @hourly and @daily. Cron is a time-based scheduling system. A cron expression defines when a task should run, using fields for minutes, hours, days, and more. NATS uses a 6-field format that adds a seconds field for finer precision. There's also subject sampling, added in 2.14. Instead of delivering the schedule message body, the server reads the latest message from a source subject and republishes it on a schedule. Picture a temperature sensor publishing hundreds of readings per second. With subject sampling, you can capture just the latest reading every 5 minutes, reducing noise for downstream analytics without touching the sensor code. A few things to know before you use this. The stream must opt in with Allow Message Schedules set to True. Once you enable it, you cannot disable it on that stream. It also cannot be enabled on source or mirror streams. If you schedule a message in the past, it fires immediately. Same thing after a server restart. Any past due schedules execute right away. You can set a NATS schedule TTL to give generated messages an expiration, so consumers can detect and discard stale deliveries. And if you use cron schedules with a time zone, watch out for daylight saving time transitions. During spring forward, an hour gets skipped and your job might not fire. During fallback, it could fire twice. Sticking with UTC avoids this entirely. That is how delayed message scheduling works in NATS. You set a header, and the server takes care of timing. One-time delays, recurring cron schedules, and subject sampling, all driven by message headers on a JetStream stream.
Cool. So now that we have sort of a high-level overview, let's run some CLI commands and some code, and we can see it actually work. All right, let's run a little CLI demo. So I've already started the server. And what we're going to do is show that the server handles delivery timing autonomously. So we'll deliver messages at specified future times without any consumer-side polling or delay logic, with knack with delay, workarounds, and things like that. So first, we're going to create a stream with allow schedules enabled. This is a prerequisite. Scheduling headers are rejected on streams without this flag. And our target subjects are schedules, orders, and reports, and they must be in the same stream because the scheduler can only deliver within its own stream. We're using allow message TTL because we want to use the optional NATS schedule TTL header. We want to mitigate stale message delivery. Say if the server goes down and recovers, all the past due schedules fire immediately. Without a TTL, consumers would process potentially outdated messages. With NAT schedule TTL, those generated messages expire automatically, so consumers can detect and discard them. All right, so we'll create the stream and then let's just verify that we created it and has the fields we need. And if we check it out, we'll see the two fields that we wanted, allow message TTL and allow message schedules, are both set to true on the stream. All right, next thing we'll do is we'll subscribe to our target subject. This is where our generated message will go. And then we'll publish our scheduled message, which will create that generated message 10 seconds in the future. Now, just to be clear how this works again, when you publish a schedule message, you're not delivering it to its final destination. You're parking it. The message lands on a dedicated schedule subject. Think of it as like a temporary holding slot. The server sees the NAT schedule header, reads the timestamp, and waits. The message just sits there on that subject doing nothing until the scheduled time arrives. Then the server produces a new message onto the target subject where the consumers are actually listening. It carries the same body and your custom headers are propagated verbatim. But the server also stamps on its own headers NATS scheduler, which points back to the original schedule subject, and NATS schedule next, set to purge to signal that this was a one-time delivery. Once that happens, the original schedule message is purged from its holding subject. The slot is empty, it served its purpose. So the schedule subject is really just a timer with a payload. One subject, one schedule, one delivery, and then it's gone, for this case. So we're going to publish the schedule message and then immediately check out the subject that's created just to show it exists. And then we're going to show that the subject is purged once the message is delivered. So first we create the schedule message. And now let's quickly look at the subject. And we can see the subject here with one message. And in a few seconds, oh, there it is. Our message is delivered. The scheduled message was sent. And if we check again, we can see that the subject is now purged. So we published a scheduled message, it sat there, it delivered, and then purged. And let's check out our message. You can see it here. And then we can see our scheduler headers, NAT scheduler with our scheduler subject, and NAT schedule next to purge, which signals this was a single delivery and the schedule is done. So the schedule subject is cleaned up after delivery. And NATS TTL, which is the TTL for our generated message. So the message sitting in the orders subject, which is actually now gone at this time of recording because I took too long to check it out. But that proved that the NATS TTL header worked, and also we were subscribed here, so we saw the message was delivered. All right, now we'll create a cron-based schedule that fires every 5 seconds. Our target stream is orders again, and the TTL on each of these messages is a minute, so they will all expire after a minute. And now when I copy this, every 5 seconds we should see a new message on the right side where we subscribed. And there's the first one, 2, 3, 4, 5. The second one, there we go. And for this, we can see that NAT schedule next has a timestamp there. It has our NAT scheduler subject there and our TTL for each message. And now because this is our scheduler subject, we can publish to it again if we want to update the recurrence rate of each message. So I'll go ahead and do that. And now we're going to generate a message every 10 seconds instead of every 5 seconds. 4, 5, 6, 7, 8, 9, 10. All right, close enough. Let's wait for one more, just to be sure. We can hang out and get to know each other, you know. Hold up, there it is. Okay, cool. All right, that was recurring, and now let's try sampling. So I did a little clearing up, and we're going to try sampling. So what we're going to do is simulate a high frequency sensor by publishing several messages and then set up a sampler for that. So in a loop, we're going to continuously publish sensor data constantly. Then we're going to publish a scheduler that will sample from that target subject where our sensor data is going. It's going to do that every 10 seconds, and then it's going to publish that sample to another subject that we have here, our scheduled target, reports.sensor.sampled. And we'll be subscribed to that subject in another window to receive those. So let's kickstart our samples. All right, the samples are flowing, and now I'll go ahead and subscribe to our target subject. And now let's publish our scheduler message for our sampling. All right, cool. Now our samples are flowing, but every 10 seconds we should get a scheduled sample in the right. There it is. And now you'll see this allows us to cut down on the noise. We don't necessarily need every single message from the sensor. Maybe we just, again, want a sample every 10 seconds to get a set of data to work with. And this allows us to do that internally with no extra logic. It's all just NATS. Okay, that was pretty cool. Let's go check out some code just to see how that looks. All right, let's check out this program really quick. The first thing we do is just set up a NATS connection. Nothing special. Then we create a stream with scheduling and TTL enabled. Again, all subjects live on one stream because the scheduler can only deliver within its own stream. Then we create the orders consumer. This registers a poll consumer filtered to orders. It calls messages to get an iterator. Then we create a scheduled message on our schedule message subject with set for 5 seconds in the future. The message parks on that subject. The program then calls orders.next and blocks. 5 seconds later, the scheduler fires, delivers to orders, and next returns it. And then we act and move on. Then we establish a recurring schedule. The scheduler fires every 3 seconds, and the loop calls orders.next. We do this 5 times, and we just print each message. So then finally, we set up sampling. We have a go routine which publishes fake sensor readings every second. We create a consumer to watch our sensors.sampled subject that we'll schedule messages to. A schedule with NAT schedule source tells the server to grab the latest reading from that subject every 5 seconds and republish it to sensors.sampled. And then we just call next on our consumer, and we just want to grab 3 messages. After that, we clean up. All right, let's run it. So we'll start it, we'll connect, we'll create our consumer, and then in 5 seconds, we should have a message appear. And there that is. Now we're going to publish recurring messages. We'll do 5 of them every 3 seconds. There's 2, 3, 1, 2, 3, 1, 2, 3. And now we'll publish a bunch of sensor data, and we'll take a reading every couple seconds. Sample. Take another sample, and one last sample. Cool. That's pretty neat. And that's our little program. And that's delayed message scheduling in NATS. One-time delivery, recurring cron schedules, even subject sampling for data reduction. All driven by headers on a single published message. If you want to try yourself, the demo and code examples are linked below. Be sure to like and subscribe if you enjoyed this, and thanks for watching.